Hi everyone, my name is Yue Ren, and also can call me Amanda. Today I will solve the demonstrations for. This is the first questions. To contact the hypothesis text for this problem, I think first we need to state the hypothesis. For the new hypothesis, the proportions of films filmed in US, Canada, Europe, and elsewhere are 25%, 35%, and 30%, and finally 10%. And alternative hypothesis, at least one of the proportions is different from the state proportion. And second, we calculate the expected frequencies. The expected frequencies are calculated based on the sample size. The sample size is the 460 films, and the proportions state in your hypothesis. So we need to the expected frequencies for US is 115, and the frequency in Canada is 161, and frequencies in Europe is 168, and airwise is 46. Then we calculate the total. And the third, we calculate the observed frequencies. For US is for this data. We calculate, finally we get this for data. Fourth, we compute the test statistic. The chi-square test statistic is calculated using this formula. You can use this formula. And where O is the observed frequencies and E is the expected frequencies. So we get this formula. Then we calculate. We can get, finally the answer is 32.23. 5. And the 5 is determine the critical values, and we can give a conclusion. The degree of freedom for this test are the number of categories minus 1. df is equal to 4 minus 1, and answer is 3. Using the chi-square distributions table or calculator, I use the calculator, and at R4 is equal to 0.1 is equal to this. The critical value for 3 degrees of freedom is approximately 6.251. And since our calculated chi-square statistic 32.23 is greater than the critical value, so we reject the null hypothesis. It's total for question 1. This is question 2. For this question, for this questions A, we need to compute the correlation coefficient for the data given. Given the data is, we can look at the we can or we can use the formula for the person correlation coefficient as this formula. Then, first we calculate the necessary sums. We calculate the x, y, and xy, and then we take this data for this formula. Then we get the final answer is 9.9966. In the question B, conduct a hypothesis test to test the significance of a correlation coefficient at the level of significance of 0.2. In these questions, first we need to state the hypothesis. Null hypothesis is there is no correlation between average orbit time and mode. In the alternative hypothesis, H1 is not equal 0. There is a correlation between average orbit time and mode. In the question 2, for the first two steps, we need to test the statistic. The statistic for the correlation coefficient is given by this formula. We use this formula for our data. We put our data in this formula. We can give that the answer is 23.46. Then the critical value for n minus 2 is equal to 4 degrees of freedom, and alpha is equal to 0.2. We look at the critical values in the T distribution table. The two-tailed critical values for alpha is equal to 0.2, and 4 degrees of freedom is approximately T or 40 is equal to 1.533. Okay, the decision since T is equally 23.46 is much greater than the critical values 1.533. We reject the null hypothesis, so it's a null hypothesis. Okay, for the C, find the regression line. We can use the regression line is given by y is equal to a plus bx. Then we put our where b is equal to this formula. So we put our data to this formula. Then the answer is 0.1862. Then we use this one. So the regression line is this. In the question D, use the regression line to determine what would be the old level with 35 minutes of daily hobby. Put x equals 35 into the regression equation. We put 35 to this one. Okay, we can get the answer is 7.917. So the predicted mood level with 35 minutes of daily hobby is approximately 7.917. So it's totally for question 2. Thanks for listening.